In the immense, silent theater of the cosmos, humanity has long been asking a single profound question. Are we alone? For centuries, we looked to the stars with our eyes, then with optical telescopes, seeing worlds of rock and gas, but finding only silence. Then, in the 20th century, we learned to listen. We built colossal ears of steel and wire, pointing them towards the heavens, tuning in to the symphony of the universe. We began the search for extraterrestrial intelligence, or SETI, a patient generational vigil, sifting through an avalanche of cosmic static for one single, structured note that could signal another mind at work. We were listening for a whisper, a beacon, a simple hello across the unimaginable void. For decades, the universe answered with the crackle of pulsars, the hum of distant galaxies, and the faint afterglow of the Big Bang. It was a beautiful, but ultimately natural chorus. Until one summer night when something broke the silence. So, what if I told you that the most compelling, the most famous, and perhaps the only credible hello we've ever received from outer space lasted just 72 seconds? The year was 1977. The world was abuzz with the dawn of the personal computer age. Star Wars was igniting imaginations in theaters, and NASA was preparing to launch the Voyager probes on their grand tour of the solar system, carrying with them a golden record, our own message in a bottle. It was a time of great technological optimism and cosmic curiosity. And on the quiet campus of Ohio State University, a unique sentinel stood guard. It wasn't your typical sleek steerable dish, it was the Ohio State University Radio Observatory, affectionately known as the Big Ear. This telescope was a marvel of frugal engineering, a behemoth covering an area of 3 football fields. It consisted of a massive, fixed, tilting reflector and a flat, movable one, which bounced signals into 2 large feed horns. It couldn't be aimed. Instead, it relied on the Earth's own rotation to sweep a narrow strip of sky across its field of view each day. It was a patient, methodical observer, tirelessly mapping the radio sky. On the night of August 15th, as the Earth turned, the Big Ear's gaze drifted across the constellation Sagittarius, a dense, star-rich region toward the center of our Milky Way galaxy. The telescope was doing what it always did, listening, recording, and printing out endless columns of data onto perforated computer paper. No one was there to witness what happened next. The observatory ran largely automatically, its findings reviewed later by a small team of dedicated staff and volunteers. In the silent darkness of that Ohio field, the Big Ear caught something wild. A few days later, a 37-year-old volunteer astronomer named Dr. Jerry Amon sat down to his routine task, reviewing the data printouts from the telescope's latest runs. It was a painstaking process, scanning column after column of alphanumeric characters for anything that stood out from the background noise. Most of it was just 1s and 2s, the faint random static of the cosmos. But as he scanned the data from August 15th, his eyes locked onto a sequence that made his heart jump. There, on the fanfold paper, was an anomaly. A string of characters that shouldn't have been there. 6 EQWJ5. To a layperson, it was gibberish. To a radio astronomer on the hunt for aliens, it was electrifying. The system used numbers 1 through 9 and letters A through Z to denote signal strength. A 1 was faint background noise. A 9 was 9 times stronger. A was 10 times stronger, B was 11, and so on. The sequence 6 EQJ5 represented a signal that started moderately at 6 times background noise, then rapidly intensified. E was 14 times, Q was 26 times, and U was an astonishing 30 times the background noise, the highest intensity the system could even display. Then just as quickly it faded, J for 19, and back down to 5. It was a perfect crescendo and decrescendo, a beautiful symmetrical bell curve. This wasn't random static, this was structured, this was powerful. Stunned, Amon grabbed a red pen. He circled the entire sequence, and in the margin he scribbled a single impulsive word that would echo through the decades. Wow! The wow was more than just an expression of surprise. It was a scientific assessment. In that one moment, Amon recognized that this signal ticked almost every box on the SETI checklist. First, it was a narrowband signal. Think of it like this. Natural cosmic objects like stars tend to broadcast radio energy across the entire dial, like white noise. But an artificial transmitter, a beacon, would focus its power on a single specific station to be as efficient and noticeable as possible. The wow signal was incredibly narrow, confined to a tiny sliver of the radio spectrum just 10 kilohertz wide. Second, and perhaps most crucially, was its frequency. It was detected at 1420.4556 MHz. This number is sacred in radio astronomy. It's almost exactly the frequency of the hydrogen line. Neutral hydrogen is the most abundant element in the universe, and it naturally emits a faint radio wave at 1420.4058 MHz. Scientists like Philip Morrison and Giuseppe Cocconi had theorized decades earlier that if an intelligent species wanted to create an interstellar hailing frequency, this would be the most logical choice. It's a universal, naturally occurring constant, a cosmic water cooler where everyone might think to gather. The wow signal was parked right next to it. Third, there was its sheer strength. Spiking to 30 times the background noise, it was a veritable shout across the interstellar darkness, far more powerful than any known natural phenomenon from that direction. And finally, there was its duration and profile. The signal was audible to the big ear for exactly 72 seconds. This wasn't a random length of time. It was the precise duration that any fixed extraterrestrial source would remain in the telescope's unmoving beam as the Earth rotated. The signal's intensity rose as it entered the beam, peaked in the center and fell as it exited. The data, 6 EQWJ5, was a perfect reflection of this journey. It wasn't a satellite, which would have moved too fast or slow. It wasn't terrestrial interference, which would likely have been picked up by both of the telescope's feed horns. But the wow signal was only seen by one. Everything pointed to a powerful, intelligent, stationary source, located deep in space, in the direction of Sagittarius. The team at the Big Ear was ecstatic. They believed they might have just made the single greatest discovery in human history. The protocol was clear: confirm the signal. They immediately trained the telescope back on that exact patch of sky, listening with bated breath. But there was nothing, only the familiar, empty static. They tried again the next night. And the next. Nothing. But here's the kicker that transforms this story from a discovery into a profound and enduring mystery. It never repeated. Not once, in the more than 4 decades since. In the years that followed, some of the most powerful radio telescopes on Earth have been turned towards that enigmatic spot in Sagittarius. The Very Large Array in New Mexico, the Allen Telescope Array in California, the Green Bank Telescope in West Virginia, all have listened, some for hundreds of hours. Over 100 separate observation attempts have been made. They have found nothing. The cosmic shout had become a cosmic ghost. Why would a civilization capable of sending such a powerful beacon across light years of space send it only once? Was it a message not meant for us? A stray beam from a transmitter sweeping the galaxy that just happened to cross our path for 72 fleeting seconds? Or was it something else entirely? The silence that followed the wow is almost as mysterious as the signal itself. In the absence of a repeat signal, science demands alternative explanations, and over the years, many have been proposed, each attempting to explain away the wow signal as a natural if unusual event. The most prominent recent theory, proposed in 2017, blamed comets. The idea was that 2 specific comets not discovered until years later were passing through the Big Ear's field of view that night. The hydrogen cloud surrounding a comet, when stimulated by solar radiation, could theoretically produce a radio signal. It was a plausible idea, but it quickly ran into problems. Other astronomers calculated that the comets were not in the exact right location at the time of the signal. More importantly, no known comet has ever been observed emitting a signal that is both so powerful and so narrowly focused at the hydrogen line frequency. The theory, while clever, simply didn't hold up to scrutiny. Another idea is an interstellar scintillation event, a sort of twinkling of a much weaker, continuous signal from a distant source, which was momentarily amplified by intervening plasma, making it appear strong. While possible, it would require an extraordinary set of cosmic coincidences to produce a signal with the exact characteristics of wow. What about a terrestrial source? Could it have been a secret military satellite or a reflected signal from a high-altitude balloon? This is highly unlikely. The signal's perfect 72-second duration and its bell-curve profile are the signature of the Earth's rotation, carrying a deep space object through the telescope's beam. A terrestrial or orbiting source would have a different signature. And what about a simple equipment malfunction? A one-off glitch in the 1970s era computer? This is perhaps the hardest to disprove, but the structure of the signal, its coherence and its appearance in only one of the 2 feed horns, make a simple glitch an unsatisfying explanation. Every natural or terrestrial explanation that has ever been proposed has significant holes. They either fail to match the data, or require a chain of events so improbable they border on the fantastic. And so, we are left in a state of profound scientific uncertainty. We have a single tantalizing data point, 6e⁻5, that defies easy explanation. Every theory has holes. The alien hypothesis, the idea that it was a genuine intelligent broadcast, remains the one that fits the data most elegantly. It requires no special pleading or astronomical gymnastics, it only requires that we are not alone. Yet science cannot operate on a single unrepeatable data point. Without confirmation, it remains an anomaly, a ghost in the machine. The WOW signal is the ultimate cosmic cold case. It represents the pinnacle of hope for SETI, and its deepest frustration. It's a story about a fleeting moment when it seemed the universe was finally talking back, only to fall silent once more. So, what was the WOW signal? A cosmic greeting from a civilization in Sagittarius? A bizarre, once-in-a-universe reflection from a passing comet? Or just plain old, incredibly unlikely static? Until it happens again, or we find another like it, the universe keeps its secret. The signal remains a question mark hanging in the stars, a puzzle that has captivated scientists and dreamers for generations. And perhaps that is its true legacy. It's a reminder that the universe is vast, mysterious, and far stranger than we can imagine. It keeps us humble, it keeps us curious, and it keeps us listening. And that, the unending quest for answers, is the real magic of science.